So we have already seen in this chapter, this functions chapter, we have already seen how to define a function. We have seen the return statement and the arguments. And now we are going to see the scope of variables. So what is this scope? So the scope of a variable is the part of the code where it can be accessed, okay? Where the variable, the variable can be accessed. And it can be a local scope, okay, which is defined inside the block of statements, okay, if the variable is defined inside the block of statements or as an argument of the function and accessible to that functions and to functions defined in it. Remember that we can define a function inside another function. It's not very common, but sometimes it's very useful. Then we have the non-local scope, okay, which happens when the variable is defined in a function of higher scope, and it's usually when the function is defined inside another function. So imagine that we are using a variable which is not defined inside the function, but it is defined in the function of higher hierarchy. We are not going to see the non-local scopes because we are not going to see functions defined inside other functions. But we are going to see also global scope. Okay, and this happens when the variable is defined in the main block of code, and it means that it can be accessed by any other function. Okay, so as you can see, these scopes define a hierarchy of scopes. We have the local scope for the variables defined inside a function, non-local for variables defined inside a higher function, and then the global variables which are accessible to any other function. We are going to see an example to see if this is a little bit clear. So in this example over here, we have this block of code. Okay, this is the main block of code. We have the first line is just an assignment. So we are assigning 1 to the variable x, named x. Okay, so since x is defined in the main scope, I'm sorry, in the main block of code, then it means that it's in the global scope, and x can be accessed from any function. Okay, in this case we are then defining this function, okay, this function which is a very simple function which is called add x with an argument y. So if in the definition of the function, okay, this is the definition of the function, okay, and we are defining a function which is called add x, and the only argument, which is a positional argument by the way, it's y. Okay, it's an argument named y. So first of all, in this function, what I'm going to do is to print the value of x. Notice that I don't have any argument here, which is called x, but however, I can access the value of x because x is a global variable. Okay, so x in this case should be equal to 1. And then inside the function, what we're going to do is to return the value of x plus y. So y, since it is an argument, this is going to be a local variable which can be accessed in any part of this code of the statements of the function. Okay, and x, however, is a global variable. So we can return x and y. We can access both variables, and we can return the sum, the addition of these two variables. So this is the function definition. Notice that I'm using the return statement to say that this function is going to return x plus y, okay, the value of x plus y. And after the definition of the function, I'm calling this function. Notice that I cannot call the function before I have defined it. So after the definition of the function, now I call this this function. And when I call this function, okay, when I call at x with a 2, this means that inside this code, the value of y, when I call this function with this argument 2, the value of y is going to be 2. So in this case, I have to print x, which is 1, okay? And then I'm going to return x plus y, which is 1 plus 2. And it's going to return 3. Let's see. So when I run the function, remember that the first thing that the function does is to print the value of x. So x is equal to 1. See? And then return x plus y. So in this formatted string, remember that we have here a string, a formatted string, because I have an f before these quotes. If you write double quotes, it works exactly the same. And now I'm going to print between these curly brackets, okay? I'm writing at x2 equal, so it's going to print this literal string, okay, at x2 equal, and then in the end, because it is in these curly brackets, it's also going to print the value of at x2. So in this case, it prints at x2 equal 3, because 3 is the value that this function returns, okay? So remember, we have the global variable here, okay, which can be accessed inside this function, and then we have this local variable y, which is an argument and can be accessed also inside this function. So this is an example, okay? So remember, arguments are always local variables of the function. And then when we have a function definition, okay, and inside the function Python finds, the interpreter of Python finds a variable name inside this function, then it's going to look for the variable value, okay? It's going to look for it first in the local scope, okay? Then it is going to be it's going to look for the value in the immediately higher scope. So if it is defined as functions, it's going to look for this value in the local variables of the functions where this function is defined in, and so on. And in the end, it's going to look for the value of this function is going to look in the global scope. So if the variable name is found in the local scope, it's going to stop there, because there's no need to go into the other scopes. And if not, then it's going to go to the other scope. And if it's not found there, it's going to be to the following scope, and so on until it reaches the global scope. In this case, I only had the global scope and the local scope because I didn't have any function. This function is defined in the global scope, okay? At x, it's a variable. Remember that when we define a function, the result is a new variable, which is of type function. So this new variable at x is also in the global scope. Okay, so it means that we have this function which is defined in the main block of code, and the only scopes where this function is going to look for variable names is going to be in the local scope and then in the global scope. Okay. Let's see another example. Well, if it doesn't find the value of this variable name, okay, because the variable name is not defined anywhere, then it's going to raise a name error. Okay, so when you obtain a name error, probably, well, you're going to see that some variable is not defined. Okay, and you have to see what, maybe you forgot to define this variable or something like that. So we are going to see another example now, okay? Now we are going to see it's very similar like the example before. We have in the global scope, we have still x equal to 1, okay? And we are going to have, after that, the function definition, but now in the function definition is going to be a little bit different. Now we are going to define another local variable, which is called also x, like this global variable, okay? So the local variable is going to be x, and this is going to be a local variable defined inside the function at 3. So now global x cannot be accessed from this function. And why is that? Because of this that I told you before, okay? If we write here sum x equal 3, okay, this is now a local variable of the function, okay? This is not changing at all the value of this x in the global scope, okay? So now if we print the value of this x, okay, of this local x, then it's going to be 3, okay, and then it returns x plus y, but now x is the value of this local variable. Okay, so let's see what happens. To call this function that I have just defined, I'm using this print, okay, and I'm calling the function inside this print function. Of course, you can call this function in any other place. When I say call the function, it means that I'm using this function, okay, with some arguments in order to return some value, or if it doesn't return, in order for the function to do what it's supposed to do, okay? So this is called call a function. When we call a function, is like that. So we are calling this function inside the print function, and when we call this function with the same argument as before too, now we obtain, the first thing that this function does, so when I call this function, the first thing that this function does is generates a local variable with value 3, okay, named x. Then it prints this the value of x with this string. So this prints local x equal 3, okay, which is the value of this local variable, and then is going to return this x plus y, just like before. But now x, the value of x is 3, so the result of adding 3 and 2 now is 5, and before it was 3, okay, you see? And then when we print outside the function, okay, after calling the function, when we print the value of the global variable x, because now we are again in the global scope, okay, when we are outside, we are in the global scope again, okay, we are in the main block of code with the same indentation. So we have this global variable, okay. The result is still 1, because the value of the global variable is not changed when I define a new function inside a function, a new variable inside a function with the same name of the global variable. Okay, I hope this is not too complicated. So by default, okay, variables from higher scopes cannot be changed inside a function if they are literals. So if I assign, we can do whatever we want with Boolean variables, integers, floating point numbers, complex numbers, or strings, and the none type, okay. And in these cases, we can do whatever we want with these variables, because they are not going to be changed, the value, since they are like constants, let's say. It's like literals here, okay. Oopsie. A literal is like a constant. But if we have a structured variable like a list or a dictionary or something like that, we can access to that variable and we can change inside this variable, okay, which is not very recommended. So remember that if you use here, for example, if you use here some x is a list or a dictionary or something, if I make this assignment, it doesn't matter, because I'm defining a new variable here named x, and this global variable is going to be exactly the same as before. But if I do something with x, like x.append something, then I'm going to change the value of the global variable, okay? So be careful with that. And now we are going to see what happens. In this example, I'm going to see what happens when I try to define a new variable and at the same time accessing the value of that variable, of the global variable, okay? Let's see what happens. So here we have, just like before, x equal to 1, okay, which is going to be a global variable. And then we define the function, which is add x plus 1 with some to some variable y. So in this case, what I'm doing is I'm trying to define a new local variable, okay? Because remember that every time we write the name of a variable equals something, if the variable did not exist before, it's going to create a new variable, okay? And in this new variable, if it is defined inside a function, it's going to be a local variable. But in the same sentence, notice that I'm trying to get the value of x, okay? X is not defined before as a local variable, so this x, what I'm trying to do is to use these values of x, which is in the global scope. So I'm trying to mix global and local scope, and it's going to raise an unbound local error. So notice here that the unbound local error, it says local variable x referenced before assignment. Well, and that's it. That's what it means, okay? This x value here, it's supposed to return a value, but in this we cannot access this value of x because I have just defined a variable named x in the local scope. So that is why I'm mixing both global and local scopes. Okay, and this error rises when I try to call this value over here. And we are going to see another example. So we are trying to do exactly what we did before, okay? So we are going to do this, and in this case I'm going to use the value of the local scope, and I'm going to change the value of the x. Well, in that case I have to declare that the x that I'm going to use inside this function is going to be a global variable, okay? A global variable means, with this declaration, okay, when I write global x, I'm saying, okay, this x that I'm going to use in the following lines, x, I'm referring to the global scope, okay, to the x of the global scope. And now, when I write x equal to x plus 1, now it means that this value of x is this value of x, and now I'm changing the value of x in the global scope with a new value, and then I'm going to add y. So I'm adding x plus 1 to y. So when I call to add x plus 1 to 2, then the result is going to be, well, first of all, I'm printing here the value of the global variable. Okay, the global variable now is x equal to 1 because I have just declared this variable, defined this variable here. Okay, so I have the first line of the code, I assign 1 to the variable x. Then I print this string over here, which is printing the value of x, okay, global x equal 1. And then I define this function, okay, and then I call this function. And when I call this function, the interpreter is going to go inside this function and is going to do all these lines. So I'm defining x as a global variable inside the function, and then I'm changing the value of x, and then I returning x plus y. Okay, so when I return, since x was equal to 1, and I'm adding 1 to 1, then now x is equal to 2. So the return of 2 plus 2 in this case, okay, because the argument in this case, the value of y is 2. When I return 2 plus 2 is going to be 4. So this is the result of this function. And in the end, when I print again this line, okay, when I write again this line of code, now the value of x that is going to be accessed is going to be after calling this function. And after calling this function, I have added 1 to the value of x. So now when I print x, it's going to be equal to 2. And that's it. Okay. Sometimes global variables may be useful, although it's not very it's not recommended to use them a lot. I mean, sometimes it's useful, so you can define a global variable, okay, a global variable, but it's not very recommended because it can be a little bit messy to follow the code. Okay, in this case it was pretty obvious because we had the function definition here and the call of the function, it was right here. But if we do this, we define the function far, I mean it's not so close to these lines of code, because we can define this function before this variable x has been defined. Okay, so if we do this far from these lines of code, okay, and then we have these lines of code far from this function definition, it's not going to be easy to understand what this is doing. Okay, because, well, it's not going to be, unless it is very well documented, it's not very easy to understand why suddenly x, the value of x, is going to be 2 in this case. Okay, so if we had defined this way, suppose that here we have a lot of lines of codes. Okay, and then we run this piece of code. The result is going to be the same. Okay, the result is going to be the same. But if we only know these lines of code, and this function is defined in some other place and not very well, it cannot be, we may not remember what this function does, then it's going to be quite complicated to understand why this function is changing the value of x. And if we don't print it like in this case, we can make some erroneous calculations assuming that the value of x is constant, as it should be. Okay, as it should be. Okay, so we have seen some examples with this easy function. Okay, and now we are going to see some of the code. Yes, we did some code regarding this linear dynamical system. Okay, and we are going to reuse this code, something similar, to make this new function. Okay, so we are going to build to define a new function called trajectory with these two arguments. And notice that here I have defined perfectly what this function does. Well, I don't know if perfectly, but at least I've tried. So here we have the summary of what the function does. Okay, and it computes the trajectory of the dynamical system, of this dynamical system, which is a linear dynamical system, discrete. Okay, linear discrete dynamical system. Then we have defined here the parameters of this function. I'm saying that x0, that x0 is going to be a float or an integer, which is the initial condition of the dynamical system. Okay, x sub 0 or x0. And then I have n, which is going to be an integer, which is going to be the last element to compute in the trajectory. Okay, which is xn. It's going to return a one-dimensional array, which is going to be a one-dimensional array with the trajectory of the dynamical system from x0 to xn. And now I have, after I have defined here the docstring, here I have what the function does. Okay, and this is going to be a linear dynamical system, which is this dynamical system here. Notice that in the arguments of this function I have not used nor a nor b, so if I use a and b inside this function, these are going to be global variables, and I'm not going to change the value of these variables since they are literals or constants, okay, they are numbers basically. And well, what I'm doing here is first, in this first line of code, I'm creating an empty array with size n+1 because I want to store from x0 to xn. So here I have n+1 elements in the array. So that's what I'm doing here. Then I'm going to assign to x and to the first element of this array, okay, to the first element, I'm going to assign the value of the initial condition, okay, x0 here. And then I'm going to make this loop, okay, and this loop is for each of these well, from 0 to n-1, okay, for the values of n from 0 to n-1 is going to make this calculation over here, okay, it's going to update the value of x to a new value of the dynamical system, okay, is computing x t+1 in terms of xt, and now I'm storing this value here, okay, so r n+1 is equal to x, which is this value here, okay, and then I return the array, and that's it, okay. So notice that here I'm using in this function, I'm using these two variables, which are global variables, but this is not so bad. I mean, I'm using these two variables, and as long as these variables don't change inside the function, and or any, well, and it can be known when you read the code, it can be known what the value is. Well, this is not so bad. It would be bad if a and b, or one of them was where, I don't know, maybe a was equal to a list, okay, or maybe params is equal to a list, which are 0.5 and 10, okay. Notice that the first element is a, the value of a, and the second element is the value of b. So I can use these params here just exactly the same as before, okay. So here I would use, instead of a, I could use params 0, okay, and instead of b, I could use params 1 because it's the second element, okay, params 1. And I would obtain exactly the same result. But the thing is that here I could change the value of params, okay. If I do params dot append 5, for instance, then the value of params is going to be changed because I'm appending a new value here in this variable, okay. I can change these variables. If I do params equal to 1 and 5, then in this case these params are exactly the same as before, and the only thing that I'm doing here is creating here a new variable, a local variable called params with these values, okay. But I'm defining here, I'm defining a new local variable here, which is called params, and the original variable is it's untouched, okay. So it's exactly the same as before, and it would be, well, this would be something different, okay. I hope you get more or less the difference between a global and a local variable. Okay, now local variables, we are not going to see much of functions defined inside other functions, so it's okay. When we have many parameters in here as arguments, then instead of defining a function, it's very useful. I mean, if we have tons of arguments here and I don't want to abuse of these global variables, a very useful thing to do is to, if these arguments are going to be used systematically in many related functions, so we have here a trajectory, we could also define the equilibrium point, we could also, I don't know, do different things. Then in that case, it's recommended to use a class. Okay, I'm not going to explain what a class is, but it's very useful for agent-based simulations. So if I have some time, I will make you some videos regarding this issue, okay? But it's not going to be in the evaluation part of this course, okay? So remember that the abuse of global and non-local variables is not recommended, okay? Because it can be difficult to follow the variable values when we are reading the code, or when someone else is reading the code. And if we use global variables, although they should be seldom used, okay, they should not change during the execution, because that is something which is very, I mean, they should be treated like constants. And that's it. I'm going to talk about lambda functions and functions as arguments of another functions, and that's it.